morning. I would like to welcome you guys to the Firearms and Fingerprints panel. My name is Mariana Cruz, and I'm a graduate student in the GMU Forensic Science program, and I'm honored to introduce the following speakers. Robert Thompson, is a Senior Forensic Science Research Manager with the Special Programs Office, Forensic Sciences at the National Institute for Standards and Technology. He has over 40 years of experience as a forensic scientist and criminalist, and is certified in criminalistics by the American Board of Criminalistics. He is a distinguished member of the Association of Firearm and Toolmark Examiners and a fellow of the American Academy of Forensic Sciences. Michelle Mahalka is a supervisory physical scientist / forensic examiner with the Lane Print Unit of the FBI Lab. She is a member of her agency's Hazardous Evidence Analysis Team and the Fingerprint Legal Advisory Group. She assisted in the development of the ACE model for the FBI's Lane Print Unit Training Program and currently co-teaches the Uniqueness and Persistency Foundational Lectures and Basic and Advanced Testimony Lectures. Thank you.
Good morning, everybody. Oh.
Quite as tall, sorry. I'm not even sure that you can all see my face over this. I apologize, I'm a little raspy. I was presenting all day yesterday as well, internally at the FBI. So my name is Michelle Mahalka. I'm a supervisor in the Latent Print Operations Unit at the FBI. I've been there now for 18 years and started as a latent print examiner, moved on to doing more of our quality control, administrative reviews, technical reviews. And now I also still do technical reviews and I teach a lot, hence my raspy voice and all the presenting I did yesterday. And then I supervise examiners on the floor. Part of the teaching that I do involves presenting to not only our new latent print trainees, but to existing examiners on the advances in testimony. That's why I was actually asked by my supervisor to come and present to you, because I was told that a majority of the individuals here will be attorneys. So just a show of hands, how many people here are attorneys? Okay. So that was accurate. I love to present to attorneys, and this is why I like to present to attorneys. I don't know that we're always on the same page. I feel like sometimes attorneys have expectations of forensic examiners that we can't always bring to fruition. Thank you. So attorneys sometimes want us to testify outside of our means. And today, one of the big things I will talk about are the limitations that we have in our discipline. We're a forensic science. We are a science, but we can't always provide definitive answers that an attorney wants to hear. So we'll go over some of those things. I also I'll start with the basics, but then I also want to go over some of the challenges that we really face from defense attorneys. So who here is a defense attorney? So this is all just prosecution. So that's very good, and law enforcement. So from this perspective, this is good because now you will get to hear some of the challenges that we've been faced with in our discipline, the latent print discipline specifically. So my standard disclaimer, it's pretty much the exact same disclaimer that Robert gave earlier. So thank you for that. I don't have to go over it. I guess all federal agencies require this disclaimer. Got to keep it legal. You guys should know that. So the foundations. What you see in this illustration here is actually a finger and a fingerprint. That's what we commonly hear people call that image that's black and white that says reproduction of friction-rich skin, a fingerprint. Okay. But on the palms of our hands and the soles of our feet, we have a very specialized type of skin. It's called friction-rich skin. And the friction-rich skin is made of valleys and furrows. Those are the white lines that you see in that illustration. That's the reproduction of the friction-rich skin. And the black lines are the actual ridges, the friction-ridge skin. And that friction-ridge skin oftentimes forms into pattern types. Now, sometimes the pattern is very simple. It's just continuous lines or what I would like to say like hills of lines. Other times there's actual definitive patterns that we see. So the photograph of the friction ridge skin, when made into a reproduction, we see the mirror image. So that's what latent print examiners are typically looking at, is that mirror image of what's actually on the finger or the palm of the hand or the soles of the feet. So we don't want to limit ourselves to thinking that fingerprints just exist on that end joint of the finger. Our fingerprints, or our friction ridge skin, exists all throughout the palm and on our feet. So if you are at a crime scene or you have evidence from a crime scene that shows a footprint on a tile kitchen floor or a tile bathroom, that's not something to be ignored. That's something that we can utilize as latent print examiners, especially if you have a suspect in mind and you can provide us with an intentionally recorded footprint. It's excellent evidence. So friction ridge skin can be used as a reliable means of identification or for identification for two basic reasons. The friction ridge skin is persistent and it is unique. These are probably things you guys have all heard of. It's sort of the basics. It's fingerprints 101. The problem with using these two terms is it's not always transferable to the impressions that examiners actually utilize. And that's one of the big things that we are challenged on in our discipline. But let's stick with just the friction ridge skin for a moment. There is copious amounts of research, not just research done recently, but throughout the years, not just research done in the forensics discipline, but in the medical professions, anatomy, physiology, that has actually upheld the theories of persistence and uniqueness of friction ridge skin. So what do I mean by persistence? When I talk about persistence, I'm saying that the skin is formed before we are born. All of those arrangements occur while the fetus is developing. Before the fetus is born at 27 weeks of fetal gestational age, those friction ridge arrangements are fixed for life. And that arrangement persists throughout your life unless you are scarred. Some diseases can slightly alter fingerprints, and then until decomposition occurs after death. So we can say that friction ridge skin, those arrangements, persist throughout life. And I love looking in the audience and seeing that some people are actually looking at their fingerprints and saying, wow, that was before I was born, maybe? That happened? Yes. So it's not only something that we can see with the actual friction ridge skin, but luckily for us, we actually have research in our discipline that shows that the friction ridge impressions are also persistent throughout life. So that recording from a three-dimensional finger or palm or foot to a two-dimensional image or impression is also persistent. What we see on a finger, actual finger, is persistently recorded throughout time and doesn't change, of course, unless there's scarring. When I talk about uniqueness, I'm talking about the fact that no two fingers, no two individuals, and even small areas on the same finger or between two fingers have the same friction ridge arrangements. That's a lot to say, but actual biological research that goes through how friction ridge arrangements form on the fetus before birth can account for how this uniqueness develops. It's a combination of things. It's a combination of our genetics, what we've inherited from our parents. It's a combination of the environmental factors that are occurring. But honestly, the biggest thing, it all boils down to physics. I hate physics. I'm a biologist by trade, okay? When I became a fingerprint examiner, I was so excited because we're talking about the biological development and I was in my zone. This was my area. I get this. And then I started doing all the research about it and I learned that it's really about physics. Our friction ridge arrangements, as we're developing, the skin has this genetic code that tells it to form ridges, to grow in ridges. And when those ridges are forming, they will always form perpendicular to the growth tensions that are acting on that particular ridge at that moment of development. And the tensions that are caused, those growth tensions, are from the lengthening of the hand primarily, or the lengthening of the foot, because our primary direction of growth when we develop is longitudinal. We get longer, okay? But we're also getting wider. The skin is growing in thickness and in layers. So a combination of all those growth tensions acting on the fetus as it's developing, in addition to the environmental factors that may be stressing out the fetus or promoting growth of the fetus at a faster rate, good diet, poor diet, illness of the mother, illness of the fetus. Those things can all play a role on how the fetus is behaving as the friction-ridged skin is actually developing. And then finally, the genetics play a role too, because genetics tell us, are you an early bloomer or a late bloomer? How thick is the skin at the time of development? How long is the finger? How bulbous is the fingertip or the palm, the fleshy parts of your hands and feet? How thick are they when the fetus develops? And all that together impacts how the friction ridge arrangement forms. And that contributes to a unique formation of the friction ridge arrangements. Again, it all happens before the fetus is born. By 27 weeks of fetal gestational age, our friction ridge skin is persistent throughout life and in a unique arrangement from person to person, finger to finger, and even in small areas. So as examiners, we have to use known fingerprints as our standard. Known fingerprints are recorded. There's many different terms you may be familiar with: a standard 10 print card. I forget that I have the computer screen in front of me here. Inked fingerprints, known exemplars, known recordings. You may have even heard, at least at the FBI, we like to say major case prints. I think the term has sort of trickled down through the state and local level as well. And a major case print simply refers to a complete collection of the recordings of all the friction ridge skin. So that would include not only the end joints of the fingers, like you see in the illustration here, but it would also include the recordings of the palm and sometimes even the toes and the feet. Whoever brought me the water, thank you. So major case prints are very important because people don't tend to just touch objects with the fingertips, okay? So if I'm grasping my cup here, mostly fingertips are pushing on this. But if I'm passing the cup to the other hand, I tend to grab it with my palm and then I hit it with my fingerprints. There's a great palm print on this cup here. Of course, it's impeded a little bit by some of the texture on the cup, but there's still a great palm print to be used. So major case prints can be very important, especially if you see, it's very easy to tell sometimes that what you have in front of you is a palm print. Try to get from a subject, and sometimes it takes a special court order, but try to get from your subject major case prints, not just a fingerprint recording. It's becoming more and more common now that most law enforcement agencies are using scanners to record fingerprints. We're almost always getting fully rolled prints that you see in this illustration here, in addition to complete palm prints. So, and sometimes even the sides of the palms are recorded, which is really great when you have somebody that's written a threatening letter and we keep getting that same recording of that side of the palm. But latent prints are different. We need those known recordings, those intentionally recorded and controlled recordings to have something to compare to. But what we actually get at the crime scene are the latent prints. So the latent prints are unintentional recordings of the friction ridge skin arrangements. And again, it can be from the palm, the foot, the fingerprints. The majority of what we see though are fingerprints. So typically what people will say is, I'm in the fingerprint discipline, okay? But that doesn't limit me to just comparing fingerprints. The issue with latent prints is they're oftentimes very fragmentary. They're oftentimes distorted. Individuals don't touch. We'll use this bottle, a little smaller. Don't just touch the bottle, but they play with the bottle. You know, they're moving it. They're twisting it. They're smearing their fingerprints. So objects are very rarely touched in a controlled manner, which makes my job difficult. But it's why I have a job, because I'm trained to recognize all of those distortions, all of the things that can affect the way a latent print is left behind. So when we're looking at fingerprints, whether you're looking at the latent or the known, we're really looking to see what sort of patterns we can find. This helps us determine the anatomical source and the orientation of a print. So if I can see a pattern and I can see sort of the outline of a fingerprint, and it's a good recording of a fingerprint, even though it's a latent and unintentional reproduction, I can sometimes tell you exactly where it's coming from. By exactly, I don't mean exactly. I mean, is it coming from an end joint of a finger? Is it coming from a lower joint? Is it coming from a palm? Or is it potentially coming from a foot? So knowing these pattern types that I'm going to show you is very important because it can help us pinpoint that anatomical source. So the friction ridges typically flow in one of three patterns. The arch is the least common, and that's for your fingertip. If we're talking about the palm, arches are very common. The loop is about 65%, accounts for about 65% of all of the pattern types on our fingertips. And the loop, unlike the arch, which is simply ridges flowing in from one side, making a rise and exiting out the other side, the loop makes a shoelace formation. It enters from one side, it recurves at the top, and it exits upon the same side. And then next you have the whorl. This looks very much like a bullseye or a target, but it's important to keep in mind that those ridges are not concentric circles. They're not connected, okay? In each of these illustrations, you see much more than just these patterns. You see that those black lines, which represent the ridges, actually stop and start. Sometimes they connect to one another. And that is actually what we use as latent examiners to make identifications, to make exclusions. Okay, Robert earlier was talking about your class characteristics and your individualizing characteristics. Well, the class characteristics are your arch, loop, and whorl. Can I determine an anatomical source? Can I say that it's actually a fingerprint? Or am I just looking at the striations left behind from a glove? That happens a lot. Agents come to me, law enforcement will provide us with fingerprint lifts, and you see little striations and you realize that's not even a fingerprint. Those are the lines left from the material of a glove. So your criminal was wearing gloves at the time. I probably won't be able to help you. So the second level characteristics, as we call them, those identifying characteristics, are illustrated here. One of the most important characteristics that oftentimes get ignored are the continuous ridges. When an examiner sees a field of continuous ridges with no starts and stops, that's a big deal. That's uncommon. It's something that we can rely quite heavily on. So continuous ridges are simply ridges that start and flow for some distance. Sometimes a ridge will start on one end of the latent print and stop at the other end of the latent print, and it has no starts or stops in between. The other three characteristics that we look at are the ending ridge, the dividing ridge, also known as bifurcations. So you may hear examiners or may read in research a bifurcation, and the dot. An ending ridge is simply when a ridge continues and then ends abruptly. And here you can see in this illustration here that the ridge is flowing and suddenly stops. The ridge in between it continues from one end to the next, and the other ridge starts at the top, continues, and ends at the bottom. Both of those that end are ending ridges. Dividing ridges is a ridge that starts, continues, and then splits into two and sometimes even more ridges. If it divides into two ridges, we see that about 26 to 30% of the time in a fingerprint. If it divides into more than that, 3 or 4 ridges, that's very uncommon. And that's a wonderful feature that an examiner can use. And then finally, we have the dot. A dot is a ridge that's as wide as it is long. And it's not very common to see them. They only occur about 3% of the time. Our ending ridges are the most common. But the wonderful thing is that you don't just have these 3 features. You have a combination of all of these features. So when I'm actually doing my examination, I'm not just looking for an ending ridge, a dividing ridge, or a dot. I'm looking to see how they're all grouped together. Are they all in the same location on the print? Are they near the center of this print where we see that whirling pattern? Are they all clustered over here near this triangular pattern that we call a delta? That's when ridges flow from 3 opposite directions and they meet. So I'm looking to see what location all of these features are in. They may even be in an area of just continuously flowing ridges with no pattern type whatsoever. The next thing I'm looking for is the type. Is it an ending ridge? Is it a dividing ridge? Is it a dot? Sometimes in a latent print, you can't always tell. Dividing ridges sometimes look like ending ridges. Ending ridges sometimes look like dividing ridges. And that's because latent prints aren't left in controlled circumstances. People twist their fingers. There's contours or textures to some of the things that we touch. And sometimes a dividing ridge may end up with a slight gap when it's reproduced. Sometimes an ending ridge might be pushed toward the ridge next to it and make it look like it's a dividing ridge. As an examiner, I don't really care if it's an ending ridge or a dividing ridge. What I care about is there an event occurring there? Okay. Is there an event occurring that's of a similar type and in the same location between my latent print and my known print? Are they in the same direction? I've looked at plenty of prints where I see 3 dividing ridges right next to each other. But if 3 of the dividing ridges in one print are all opening downward, but in the other print, 2 are opening downward and 1 opens upwards, I'm not looking at the same print. And then there's spatial relationship to one another. All of these ridges from one feature to the next, that count of ridges has to be consistent. And sometimes people will ask, well, what sort of measurements do you take in the latent print discipline? I don't get a ruler out. I'm not using some sort of, fancy instrumentation that Robert was talking about earlier. We don't do that. We are simply counting the number of ridges from one feature to the next to ensure that they are the same spatial relationship from one another. These are the 4 criteria. This is not a point system. I can't say I have 8 features in common between my latent print and my known print. But what I can tell you is there are 8 features here. They have the same spatial relationship from one another. They're in the same location of the print between the latent and the known. They're of the same type, and they open in the same direction. So I'm not just giving you 8 features. I'm giving you a lot more than that, because every feature has a relationship to all these neighboring features. So it's much bigger than just a point counting system. So when we talk about friction-ridge prints, we have to remember that examiners don't look at the skin. We actually look at impressions. And this is probably one of the hottest topics we've heard in the last couple of years. There's maybe 3 or 4 hot topics that have been coming up. And one of them that comes up from defense attorneys is, I'll give you uniqueness and persistency. I'm not even going to argue with that, because you're going to give me a lot of research that supports that the development of friction ridge arrangements results in unique friction ridge skin. And you're going to give me a lot of research that shows that friction ridge skin is persistent throughout life, that those arrangements don't change from the time we're born till the time I die. But you don't look at the skin. You look at an impression. And that's going from a 3-dimensional finger with pliable skin. I mean, go ahead and take a look at your own finger, press on it. It squishes, okay, to use the technical term. It squishes, it's pliable, it moves. And when it encounters an object, it can move, it can stick, it can slide. So it does a lot of things, and it can move in every direction. You can twist it, you can push it to the right, to the left, up and down. That is going to affect what your actual friction-ridged skin looks like in a two-dimensional impression, all of those distortion factors. If we're touching a textured surface, sometimes I can leave a very controlled impression on a very textured surface. For example, the end of this microphone, it has striations in it. That's going to hinder how my friction ridge arrangements are reproduced on that object, to the point that sometimes I can't even use the friction ridge impression. So what defense attorneys want to know from us is, if we're not looking at the actual skin, we're looking at the impressions, how do we use those foundational premises of uniqueness and persistency to then support that I can make an identification or an exclusion using the impression? Well, luckily for us, research does support that friction ridge impressions are persistent throughout life. You can look at one recording from an individual, even as an infant. Luckily for us, the impressions of infants, their feet are oftentimes taken at birth. So you can look at that impression if it's good enough quality. Nurses aren't trained latent print examiners or fingerprint recorders, so sometimes they don't look like much of a footprint, more for nostalgia than comparison purposes. But if you do look at that footprint and compare it throughout that person's life, those friction ridge arrangements on that footprint do not change. So research was actually conducted by Monson and others through an FBI study. It was published in 2019. It's a very recent study that actually shows not only is the friction ridge skin persistent throughout life, but so are impressions. And they collected impressions over the course, in some situations, of 58 years. They were looking at the recordings over 58 years, and the impressions were upheld the concept of persistency. Now, when we talk about uniqueness, it's a little bit different. We have two things kind of going against us with uniqueness when we talk about impressions. Number one, we are now, and we'll talk about this in a little more greater detail later, we are not allowed through the Department of Justice mandate to talk about our evidence as being unique. So the latent print, in my case, is evidence. And I am prohibited from using the language unique when talking about my evidence. I can say that it's discriminable, it has discerning qualities. I can use language like that, but I cannot say unique. It overstates, the term unique overstates exactly what has been shown in research. The second reason now actually is the research. Research shows us, experience shows us, that you get to a point when a fingerprint can be so distorted or have such a small area that it is no longer unique, one impression to the next. If I only have 3 features, those features are all ending ridges. Ending ridges are the most common feature that I will see. There is a very good chance that that is not a unique combination of features. I do not have enough area to move forward with a comparison. So when we talk about fingerprints, the impressions, examiners have started using the terminology discriminability. Do I have enough information, enough clarity and quantity of information that I can discriminate one print from another? Are there differences that force me to say that these 2 prints were made by different individuals, by different fingers? Or do I have enough information and agreement with no differences such that I would not expect to see that amount of information repeated in a print from another source, that I can make an identification decision? The best research we have to support discriminability are twin studies. Who else is going to have the most similar fingerprints but twins? Genetics plays a role. Environment, when the fetus is developing, plays a role in the friction ridge arrangements that we have. So identical twins, they share genetics, they share a fetal environment. If anybody is going to have the same fingerprints, it will be identical twins. Well, luckily for you guys, I'm an identical twin. I've studied my fingerprints, I've studied my twins' fingerprints, and they are not the same. However, we do have the same pattern types on all of our fingers. We also share the same pattern type with our father. My mother and my brother share the same pattern type, but their pattern types are very different than my sister's, my father's, and mine. So genetics does play a role, but when we look at those second level characteristics, the ending ridges, dividing ridges, dots, and a combination of those features, we're very different people. There have been twin studies conducted that for many years, actually. There's quite a few of them. There's a new one that should be published in the next year or two, I'm hoping. So we have something a little bit newer, but mostly we fall back on two publications, one by Lin and others, and another by Shrihari. So if you see individuals, examiners, talk about twin studies, this is typically what they will fall back on, are these two. What I like about the Shrihari study, this was published back in 2008, before we had issues with talking about uniqueness as evidence as unique. Back in 2008, Shrihari was already using the term discriminability. His publication in his twin study is actually called The Discriminability of Fingerprints of Twins. And what he did show, using a study group of over 200 twin sets, he was able to show that no two twins had the same friction ridge arrangements. And he didn't use their skin. He used the impressions. That's what examiners use. So it's a very powerful study for us. The Lin study, published in 2012, it's newer, so a lot of examiners like to fall back on that one, also shows that no two twins had the same friction ridge arrangements. So you might wonder, when we get evidence into the laboratory, how do we actually find latent prints? Most latent prints are invisible. Now you're probably all thinking, I don't know, my kids used to leave a lot of messy prints on the windows. I always found myself cleaning those screen doors or the car window, little fingerprints everywhere, right? Or you just picked up your glass of water. When you put it down, you notice there's a fingerprint on it. So some fingerprints are visible to the human eye, just looking at it, but most fingerprints require some sort of processing to be visualized. And that can be a chemical, a light source, a powder. There's different things that we use depending on the type of evidence. So for example, here you see an examiner, and some of you may know her, Melissa Gish. She presents quite a bit as well. Melissa Gish is processing a porous item. She's processing a piece of paper, okay? When we touch items that are porous, such as a piece of paper, the friction ridge arrangements reproduce onto that paper and actually soak into the fibers. We can also get fingerprints on fabric. If the weave of the fabric is too large, we oftentimes can't develop a usable fingerprint. The weave is just too big, or the fibers tend to be too almost fibrous. However, if there's a tight weave, like on a nylon bag, sometimes we can get pretty good fingerprints. If you have a pretty tight weave on a bed sheet, we can sometimes get a usable fingerprint. So it really depends on the type of porous material. But paper, receipts, notebook paper, books, all of those typically retain very good fingerprints. And we do use different types of forensic light sources. The most common chemical that's used, I think, throughout the fingerprint discipline now is indandione, and then also physical developer. And they will use different chemicals in our fingerprints to detect the print. So sometimes a print is left by touching our face, touching different items, and then leaving oils behind. Sometimes fingerprints are left because of sweat. Sweat is a type of substance that is detected by one chemical, whereas oil is detected by another chemical, which is why it's very important when examiners do process items, they use a very particular sequence to make sure that if they're washing something away with water, they're not washing away the sweat prints before they've actually developed the sweat prints. So there's a specific sequence in which examiners will test the evidence. Porous items, or sorry, non-porous items, as you can see in this illustration, the examiner's holding a gun, a pistol. So something that probably Robert will be getting from me after I do my tests on it, will also be processed in the laboratory using similar techniques, but not the same chemicals. The wonderful thing about a non-porous item, and people are always blown away by this, the best way to develop prints or see a fingerprint on a non-porous item is with super glue. So we actually use super glue fuming. There's very almost archaic ways to do it and very advanced ways to do it in chambers with proper heating and different types of glue. But regardless of the method that's used, super glue is one of the best ways to develop a print on a non-porous item. Those images or those impressions that are formed by the super glue can be enhanced using dye stains so that they become more visible. The most common thing that examiners do before utilizing super glue is always to do a visual and alternate light source exam. Sometimes fingerprints, because of the lotions or their the products they use in their hair, actually make their sweat or the oils fluoresce. So we always try to use some sort of forensic light source, a laser, a UV light, to detect the fingerprints before we move on to using any chemicals. And then finally, there's the adhesive process. A lot of people don't realize this, but tape, the adhesive side of stamps, the adhesive side of labels are fantastic places to find fingerprints. So we've had agents submit evidence before, and they say, yeah, just go ahead and process the paper. You only need to do the top page. And I'll say, well, there's tape on the second page. Do you want me to remove the tape and look at the adhesive side? Because somebody had to put that piece of tape on that paper when, let's say, they tore the paper. They wanted to put it back together, make sure it was stuck together as one piece. Somebody had to put that tape there. I'm more likely to get a good fingerprint on the adhesive side of the tape sometimes than I am on that paper. People flip pages and they just sort of flip at the bottom of the page. They don't always leave good fingerprints. But when I take that tape, I'm sticking the tape to my friction ridge arrangements. It's the same thing that a crime scene technician would do when they dust for a print and then they put the adhesive side down. They're literally lifting back up on that adhesive side, those friction ridge arrangements. Well, when I touch the adhesive side of tape, I'm just leaving it there right away. So anytime you have an adhesive surface, you want to make sure an examiner is taking a good look at that because they can leave prints behind. With the adhesive, adhesive side of tape, we actually go through and make sure that we process the non-adhesive side as well. But then really it's just a fingerprint powder mixed with a detergent that's brushed onto the adhesive side and rinsed off with water that's used to detect prints on the adhesive side of tape. We've actually had situations where examiners have been at a crime scene and they didn't have the powder available to them or a detergent available to them. They literally took the carbon from a toner cartridge in a printer, mixed it with some Dawn detergent, did a test strip on a piece of tape to see if it worked, and then processed the evidence using that because that's all that was available to them. So getting prints on the adhesive side is a great way to get prints. Well, once we have prints, we actually have to compare the prints. Sometimes we have the good fortune that you have a suspect and you submit the known records to us. Other times we don't have that good fortune and we will be comparing any prints that we detect in our latent fingerprint database or our known fingerprint database. Currently, it's known as NGI, Next Generation Identification. Most of you are probably familiar with the term, though, AFIS or IAFIS, the Automated Integrated Fingerprint Identification System. The latest version is Next Generation Identification. So, as examiners, we go through a series of steps called ACE-V. When I talk about my series of steps, I'm just doing ACE. The V stands for verification. Another examiner is doing the verification. So it's not really my comparison process or my series of steps to include verification. That's a quality assurance measure. So this acronym stands for analysis, comparison, evaluation, and verification. Simply when I'm doing an analysis, I'm looking at the latent print long before I've seen a known recording, and I'm looking to see what is available to me. Can I determine the anatomical source? Can I orient the print tip up? Do I see ending ridges, dividing ridges, and dots? Do I see rarer features than others? Is there an area I can focus on because it has such a combination of features that I would not expect to see that particular set of features repeated? It's a good place for me to start when I'm comparing. Is the print suitable? Does it have a high enough quality and quantity of information that I can actually move on to the comparison phase? If I answer yes, I move on to the comparison. And just like Robert was showing earlier with the comparison microscope, you're literally putting the fingerprints of the latent print and the known print side by side to compare all of those features. And then I will move on to my evaluation phase. My evaluation phase is where I say, do I have an identification, an exclusion, or an inconclusive decision? Luckily for you guys, the terminology is really similar in the forensics. So the terms that Robert used earlier, same in fingerprints. So to give you a little illustration of what we actually do, and examiners don't mark a fingerprint like this. However, as we're moving more into the digital world, we do mark our fingerprints. We document everything we see digitally. We do that starting with the analysis. And so while an examiner may not mark it up quite this well, this is for illustrative purposes for you, this is all the information that the examiner is looking for when they're doing an analysis. Looking for continuous ridges. Everything you see in orange is a continuous ridge. Dividing ridges. Everything you see in yellow is a dividing ridge. Ending ridges are marked in blue. This particular print had no dots. Remember, dots are the rarest feature. So if I have enough quantity and quality of information to say that the print is suitable to move on to comparison, I will claim that print. I will say that the print is of value or suitable for comparison. How do I make that determination? The big question, the million-dollar question, how do I know I have enough information? Okay. SWIGFAST, the Scientific Working Group for Friction Ridge Analysis Study and Technology, they put together a graph. The graph isn't meant to be a conclusive mark on if you're in the green region, you can compare a print. If you're in the red region, you absolutely cannot. If you're in the yellow region, it's a questionable print. Okay. However, it is quite a good guideline, and research supports this. Research studies such as the white box studies conducted by Ullery and others support that examiners actually look at what this graph shows, that right around 7 features here, if you move up and you have a high quality print, when you have about 7 features, you have enough information, enough quantity and quality of information to say that you can move on to the comparison phase. However, if you're way down here, studies show and support what this graph shows, that examiners will never say that that print is suitable to move on to comparison. And then prints here are definitely suitable to move on to comparison. So let's move on to the comparison. I think I'm running out of time. I think Robert robbed me of some of my time, but that's okay. So we'll try to get through this. Whoop. Just blacked out the screen. Okay, so the comparison. When we compare prints, we're actually placing the prints side by side. We're going and following along each of the ridges one by one and noting all of the features that we see. And we do the same thing in the known recording. Oops. Until we get to a point where we have actually compared the entirety of the print. And if I see that all of the features are in agreement with no disagreement and features that I would not expect to see repeated in a print from another source, I move on to make an identification decision. Those two prints are identified to one another. The majority of our decisions are exclusion decisions. They are not identifications. In that instance, we would not see all of those dots in agreement, and there would be sufficient information in disagreement to conclude an exclusion. So the exclusion decision is when the two prints were made by different people. An inconclusive decision is typically made when I don't have sufficient agreement between the latent and the known, mostly because they're not the same area. For example, a fingerprint known record usually records the end joint of the finger, but it doesn't always get the tips or the sides. So inconclusive decisions are oftentimes made because the latent print was left on the tip of the finger or the side of the finger. An identification is when we can say that two prints were made by the same person. I'm not going to lie to you. My agency has much more in-depth definitions when describing these three conclusions. We go into the basis for our conclusion, the limitations of our conclusion. However, every agency has a different definition. That's one of the limitations of our science, is that we don't have standardization across the agencies about our definitions. We all have slightly different definitions. However, these are the basics. This is the basic definition of ALDAs, and every single agency will define exclusion, inconclusive, and identification, at least to this extent. So the verification phase is the last phase of that ACE-V series of steps that we use. When we do a verification, it's simply one examiner looking at the work the other examiner did and seeing if they reach the same conclusion. Most agencies have a policy that verifications are done on all identifications. Blind verification is when that second examiner does not know the results of the first examiner. So they don't know if the first examiner reached an identification, an exclusion, or an inconclusive decision. So blind verifications actually remove bias. Robert was talking earlier about cognitive bias. In an attempt for our discipline to remove that cognitive bias, especially in my agency, we do it in those high-risk areas where there's only one single print, one single conclusion. We will send, regardless if it's an identification, an exclusion, or an inconclusive decision, we will send that out for a blind verification so we can remove bias to ensure that the initial examiner wasn't biased by the case details, that they knew that this was a horrific homicide of a child. We want to ensure, because the suspect was actually named. That's usually an argument defense likes to make. Okay, this wasn't generated through an automated search. They named this my suspect, so you were clearly biased. Well, when you send it to a blind verifier, bias is removed from that equation. So the limitations that we face. There are numerous limitations, and scientific research is sort of the foundation of why we have limitations. We cannot tell you, and science supports this, we cannot tell you when a print was left behind. We cannot tell you the significance of the touch. Was it done during the commission of a crime or when an individual was simply handling an object for non-criminal purposes? The conditions or the circumstances of when that print was left behind. We can't tell you why no usable prints were detected. The agent says, I have him on video committing the crime, touching the doorknob, but we find no fingerprints. Well, were they wearing gloves? Were the prints wiped away? Did several other people touch that doorknob and wipe the prints away before it actually came to the laboratory? But I can't tell you exactly why prints weren't left behind. I cannot provide you a predictive error rate. I can tell you that there are error rates that research provides us, but I can't apply research error rates to criminal casework. Error rates in research are always done with ground truth when we know the conclusion. As an examiner working casework, I never know the true conclusion. I am trying to use the information in front of me, the visible data in front of me, to reach a conclusion, but I'll never know ground truth. And so I cannot provide you with an error rate that is outside of what research shows us. In addition to that, as an examiner, I'm continuously learning from my mistakes if I make a mistake. Every agency that I know of has a policy in place to correct mistakes, correct the behavior if there's a trend, and examiners are much less likely to make that same mistake. Research also shows that errors occur more often with more difficult comparisons. So to apply a single error rate to every single comparison is not something that we do in our discipline. So I cannot provide a predictive error rate into the court. However, I can tell the court what research shows. And I'm very happy to report to all of you that research shows that latent print examiners are highly accurate. We are extremely accurate when it comes to identifications. One study, the black box study by Ullery, says that we have a 0.1% error rate. And that's for identifications, for our false positive rate. Okay, so we very rarely erroneously identify a person. We're not quite as good at exclusions, but we still have a very low exclusion error rate. So missing the identification. Our error rate for misses, according to that particular study, is 7.9%. So it's a little bit higher, not 0.1%, but it's still extremely low. The important thing is we can provide the court with an error rate, just not a predictive error rate for an individual examiner. There's just no way to do it yet. Maybe in the future, we'll come up with some fantastic statistical way to do that. It's not with us yet. I also cannot say that I have a zero error rate. We're humans. Every examiner is a human. That's the thing about fingerprints. We rely on the examiner to apply that series of steps, the ACE series of steps. And so it's really on that examiner to reach the conclusion. It is subjective. It's based on visible data. I can show the court. I have no problem providing the data that I relied upon to the court to show what I relied on. However, it's still a subjective decision. It's an interpretation made by the examiner. And I've had questions in court that if it's subjective, how do you call yourself a science? All sciences are subjective. Every single science, except for mathematics, if you want to call mathematics a science, relies on the interpretation of data. Every doctor going in and listening to a list of symptoms is interpreting those symptoms and applying a diagnosis. Every science relies on interpretation. So every science has subjectivity. That the print is identified to an individual to the exclusion of all others is another thing I will never say. I cannot tell you that I've actually compared everybody. So I cannot say that this is to the exclusion of all others. That is an overstatement. I can say that I would not expect to see this amount of information repeated in a print from another source. But to actually say I've excluded every single person in the world that ever lived, has lived, and will live, I cannot say that. I also, as stated before, cannot say that a latent impression is unique. So some of the challenges, and I was told earlier that you guys have already discussed some challenges, so I'm just going to take, well, I'm over time. Do we want to go through the challenges real quick or on schedule? Okay, so I'll just say this. Most of the challenges that we're facing nowadays deal with documentation. So when you are talking to your examiner, ask about their documentation, how they have documented their findings. Have they documented their analysis, their comparison, and their evaluation decisions? The other challenge that we're facing a lot deals with the uniqueness concept and whether the examiner is stating that prints are unique or using the terminology discriminable. because it is believed that the term unique is misleading to a jury and is an overstatement of what we can actually support. Those are probably the two biggest arguments that we're getting in the courtroom. So relying on documentation is very important, and knowing all of the challenges out there. Just to put it out there for your recognition, 4 big external reports were written since 2009. The NAS 2009 report, that was Congress mandated that the National Academy of Sciences look at all the non-DNA forensic science disciplines, and they published a report. In 2012, NIST, Roberts Agency, National Institute of Standards and Technology, published a paper on human factors. I actually make the human factors report, many of the chapters, mandatory reading. It's amazing information for examiners, but it's also a tool defense attorneys use to say why we might be making mistakes. And that's why I require our examiners to read it, so they make fewer mistakes. Awareness is a big thing. The 2 more recent publications that are external reports, I believe you guys have talked about, according to my conversation with Robert, the AAAS, the American Academy for the Advancement of Sciences. They published a report in 2017. But more commonly, what's being used is the PCAST report. Okay, and my understanding is the PCAST report was addressed quite a bit. So know those, your examiners will know those reports, talk about them. Because if your examiner is being challenged on the stand by defense, especially in an admissibility hearing, those reports will likely come up. So will documentation, and so will so might the concept of uniqueness and the overstatement of some of our language. So those are some key areas to focus on. I apologize that I ran out of time. Are there any questions quickly? If not, I'll stay here and you can come and talk to me afterwards. And I thank you for your time.